morning, my name is Anders Tengberg. I work as product manager and scientific advisor at Andera. Please join me and the municipalities of Landskrona and Helsingborg today as we do the yearly service and data download from their Seaguard instruments, which they use in the Öresund area. You see it behind me here. It's in the south of Sweden, in a strait between Sweden and Denmark. Seaguard instruments are very flexible and sensors can be added and removed as desired depending on the deployment. Here we see two versions, one with a single point Doppler current sensor, one with an acoustic profiling sensor. And you can see that there are several sensors added to the top plates of these instruments. For example, here a wave and tide, a conductivity, temperature. There is here a remote sensor added on a cable, and by switching off the power you can add and remove sensors to the instrument. Here I will add an oxygen optode to this instrument. Power is switched off. I can insert it, and then I need to tighten it with a set screw from the side. Data are stored on an SD card, which you put into this slot here internally during deployments, and you can also have real time, as in this case we have here. These instruments have 4 analog ports where you can add analog sensors to them, and you can also add serial sensors. And in this case we needed, in one of our projects we needed to have a pump, and then we added it to one of the analog ports, and the pump running on and off is controlled by the analog port. We have used that also to control UV light for anti-fouling. Batteries, you can either buy them pre-made from us, alkaline or lithium, or you can make your own battery packs and include in this empty shell. Batteries are stored in the backside here of the instrument. To set them up, we use software which is called RealTime Collector. It's one software handles all our instruments and sensors. It automatically recognizes which sensor or instrument is connected. The RealTime Collector software is used to set up all our instruments and sensors. You can connect to many real-time systems simultaneously via COM port, IP or USB. When a sensor or an instrument is connected, you have access to all available settings for that device. You can set up all sensors that are connected to it. Data from up to 70 real-time systems can be handled and sent to dedicated software for presentation and stored in a database. Data Studio 3D is a graphical software to read instrumental data and obtain rapid overview of the data quality and ongoing events. First, the data and settings are imported. Then data to be plotted and exported can be graphically limited in time, and where there was an acoustic Doppler current profiling sensor connected, the number of bins can be limited through a graphical interface. Different types of graph can be made, including plots, line plots to compare different parameters with each other, and 2D plots to look at quality and ongoing events. Also, you have possibility to make 3D plots and progressive vector diagrams and scatter plots. And finally, you can export data in CSV format to be imported into other software. So this is the boat we will go out with from Helsingborg Harbor. It's called Sabella, and it's a small research ship. The intention today is to recover 2 instruments. So now we are going out from the harbor of Helsingborg. On the other side we have Denmark and the harbor of Helsingør, and maybe you can see here that's the castle, which is supposed to be where Hamlet lived, although he was not a real figure. The marine environment here can be regarded as healthy. The ecosystem is dominated by a low salinity community at the surface and a higher salinity community at the bottom. This consequently leads to different types of benthic fauna communities, which you see in this picture. You should notice the Haplops community, a crustacean community which disappeared in 2007.
It's marked in red at the bottom. It is believed that they disappeared because there was low oxygen conditions measured in the summer of 2007 during reproduction, and then followed by low oxygen also in the autumn. Here we can see the value of measurements, the continuous lines, compared to sampling the dots. In an 8-year period, the sensors reported 130 days of low oxygen, while the samples reported only 6 occasions of low oxygen. There is high ship traffic in this area, with ships going in and out to the Baltic Sea, and there is ferries every 20 minutes between Sweden and Denmark. 2 of these are electrical, probably still the largest electrical ships in the world. As we approach the first station, we pass a navigational buoy, which measures currents in the water column and reports into the Swedish national system Viva, with 150 stations in real time. Arriving to the first system, you use an acoustic transmitter to get the distance to the instrument, and then you release it, and it will hopefully rise to the surface. Now we have to recover the weight, because the system is connected to weight on the bottom. Now, what species is this?
It's Tubularia indivisa. It's a hydrozoa. 44.
My name is Therese Hansen. I work as an ecologist at the municipality of Landskrona.
And my name is Stina Vuxan, and I also work as a marine biologist and environmental strategist in the
You have data series now of measurements since about 15 years back. Why are you doing these?
To follow the marine environment is very important for us. We have a program to monitoring the water out here, and one of the most important factors for us is to know the oxygen level of the bottom in the water, to know how the animals are doing. So it's a very important information to know how the ocean is doing for us.
We don't have the same kind of program that Helsingborg does, but still it's an important factor for us to see how the status of the Öresund is doing. And together with Helsingborg, we can have a bigger area of the ocean that we can monitor. And we've been doing this in 2012, I think, but you have doing it for a bit longer.
Yeah, 2005. Yeah.
So how does the fauna? How is the environment here?
In general, if you look over like 20-25 years, it hasn't changed very much, but we have seen some differences, like that some species have disappeared, and thanks to the information from the oxygen sondes and stuff, that maybe it could be due to the low levels of oxygen some years, that the animal has disappeared from the area.
So why do you need to measure? Can you not just go out and take samples like monthly or something like that?
It gives us a better picture because we can look at the national measurements, and they go and compare, and the national measurements goes out once a month, but we ask ourselves what happens in between that time every month. And with this sonde now, we discovered that it could be oxygen depletion the whole time for 8 weeks in between there, and that's a very long period maybe for the animals, and that could actually be the thing that changes why we see what we see.
Yeah, it can be low levels of oxygen in between the measurements if you just do it once a month. And now we can have a fine, nice graph that we can see throughout the year how
Yeah.
and follow it.
And get a bigger picture of how long these oxygen depletions lasts and stuff, and also how it varies together with the temperature levels and salinity. So it gives us a better picture to understand what we measure when we look at the animal community out here. Why is it reacting like it does? What are we actually looking at?
So you also take samples for bottom fauna. How often do you do that?
In Helsingborg, we take once a year, both on the deep bottoms and a bit more shallow bottoms too.
And for other parameters as well?
Yeah, we measure pollutants also in the sediments and in biota. But it's the animals and the pollutants, and together with this information from the sound, it gives us a better picture to understand what is affecting the environment out here. We have to know to put in the right measurements from us on land. What should we
Prevent it.
yeah, to make it better? What do we need to do?
Thank you.